The standard Eantime configuration, as installed from the installation media, will run without modification on any PC-compatible host. There are configuration options to meet specific needs for development and deployment of an Eantime system. Some of the configuration options are linked to Eantime itself, e.g. memory used by the kernel, networking, licensing or automatic loading of applications. Other options are only relevant for the Eantime for Windows configuration, where you want to specify Eantime interaction with Windows. In which way should Windows react on faults in Eantime nodes? How many processor cores run Eantime? Is there a need for a virtual Ethernet link between Windows and Eantime? Which devices get passed from Windows to Eantime? Yet other options are only relevant for the Eantime distributed RTOS configuration. In this configuration you need to care about booting the Eantime nodes while the Windows interaction is not relevant. So, you set all the parameters from the GUI-based client of the Windows SDK. The server is the Eantime distributed RTOS host, which was built as a result of the initial installation. There are three ways to start the Eantime configuration. 1. Click on the Eantime status monitor in the system tray, then select Eantime configuration. 2. Open the control panel System and Security and select the Eantime configuration panel. 3. Select Eantime configuration in the Eantime program group. The node management displays all hosts that currently can be accessed by TCP/IP and also run Eantime nodes. It also shows the current execution state of the Eantime nodes. In our case there are 4 hosts with 6 Eantime nodes. Host KW8510W runs an Eantime for Windows configuration. Local indicates Windows is running on this host, with one Eantime node named Node A. Node A is not running. Host NUCPC runs an Eantime distributed RTOS configuration, indicated by RTOS, with 2 Eantime nodes named Node A and Node B. Both nodes are up and running. Host 10A System OPC runs an Eantime for Windows configuration. NTX proxy indicates Windows is running on this host and allows other Windows nodes with Eantime SDKs to debug Eantime applications on the Eantime nodes of this host. This host has 3 Eantime nodes named Node A, Node B, Node C. All these nodes are up and running. Host FITPC runs an Eantime distributed RTOS configuration, indicated by RTOS, with the nodes hidden. The System tab defines the interaction between Windows and the Eantime nodes and is global for the host. The Eantime nodes can be configured individually to match the requirements of the application running on the node. Detailed explanations and descriptions are found clicking the Help button. Eantime needs memory for its own kernel and to run Eantime applications. When repartitioning the host to share its memory with Windows, we specify the amount of memory for Eantime. There is no single figure on how much is needed, but a minimum of 16 megabytes is recommended. Windows limits the amount of memory that a driver can allocate. If you need more, you will have to use boot options. With the introduction of multi-core processors, you now have a choice of how to use these cores. Dedicated mode gives the best possible determinism for Eantime at the cost of a complete core. Dedicated is the only mode for Windows 8 and higher. Shared mode is a compromise between performance and cost. It only is available for 32-bit versions of Windows up to version 7. A Windows node can display text output from any Eantime node. Windows will open an individual RTIO console window for every Eantime application when it opens standard I/O, std-in, std-out, std-air. The characteristics of the RTIO console window, specifically the buffer size, can be configured. A Windows node also can be configured to capture and handle faults that happen on Eantime applications on any Eantime node. Examples of such faults are dereferencing illegal pointers or scratching beyond shared memory. In case of a fault, Windows can start one of the debuggers supported with Eantime or start custom programs that may diagnose the situation with the application. Syslog messages by default are saved on the local host. This may be inconvenient for distributed systems that cooperate and you want to see the sequence of events in one place. In such situations you can collect syslog messages on one Windows node. There are many parameters for the kernel, each coming with its own help information. During development you should not enable automatic starting of the kernel. If for some reason the kernel or one of its auto start applications does not work, you are stuck. In that case, you have to press F8 during the start of the boot phase and choose safe mode. If you are replacing two separate systems with an Ethernet connection by a single system running both Windows and Eantime, you can save yourself rewriting all networking code in the Windows and Eantime applications when you use the Virtual Ethernet driver. The Virtual Ethernet driver behaves like an ordinary network driver in Windows, but instead of talking to a NIC, it communicates with Eantime nodes on the local host. Each node has its own virtual NIC. Windows also has one. All of these virtual NICs can have a unique IP and are connected to an internal switch. You can also configure Eantime networking. A NIC must be passed from Windows to Eantime and there must be an Eantime driver for it. Eantime comes with support for various versions of Visual Studio. Whenever an install button is enabled, it indicates that the Visual Studio version has been installed on your computer, but no Eantime support is currently configured for it. In a similar fashion, when an uninstall button is enabled, support for that Visual Studio version has been installed. When you install or uninstall support for a Visual Studio version, the next time you start that Visual Studio, it may take some extra time to reconfigure its help files. Visual Studio 2017 currently is the newest version supported. The Eantime Device Manager shows the same kind of information as the Windows Device Manager. It also shows the use of interrupts in the right-hand pane. When you right-click on a device, you can pass it between Windows and Eantime with various options. Pass to Windows, if it had been earlier passed to Eantime. Pass to Eantime with legacy interrupt. Be careful that the same IRQ is not used by a Windows device. Only do this if there is no interrupt conflict. Pass to Eantime using polling, no interrupt. The Eantime driver polls the device regularly. Be careful and have enough spare processor cycles on this Eantime node. Pass to Eantime using MSI. The Eantime driver uses an MSI interrupt which does not cause a conflict with Windows interrupts. Use this option whenever possible. If there is more than one Eantime node on this host, you must choose which node gets control of the device. When a device is passed to Eantime, a driver is installed in Windows that only claims the resources, so that Eantime applications can then use them. The Eantime nodes either can be configured interactively using the web-based interface or you can directly transfer tested configuration files to the host using FTP. Each node can be configured individually to match the requirements of the application running on the node. Eantime nodes run identical binaries, no matter if they are used in an Eantime for Windows or Eantime distributed RTOS configuration. In terms of configuration, the two main differences are: Windows interaction only applies to Eantime for Windows configurations. Boot configuration only applies to Eantime distributed RTOS configurations, because the Eantime node directly boots from accessible media without the help of Windows. Therefore, Eantime configuration options for the kernel, networking, initial application loader and advanced settings, i.e. all settings that are not related to Windows interaction, are similar in Eantime for Windows and Eantime distributed RTOS. While the System tab in Eantime for Windows configures the Windows interaction, the System button for a host with distributed RTOS nodes allows to get global boot options configured. In an Eantime distributed RTOS configuration, options are saved in configuration files on the host during the interactive configuration done via the web interface. It is not recommended that these files are changed directly. Rather, use the configuration interface. There are many parameters for the kernel, each coming with its own help information. Parameters for networking. Initial application loader and advanced settings are all concatenated from the kernel configuration screen. If you want to reinstall, you can skip formatting the boot drive. This may help to keep your recent settings. Another way to keep the setting is to use FTP to get backups of a known working image of your system and FTP it into your host right after installation from USB Media. Many options are shown for each node. All options have respective help information. Eantime is protected by electronic licensing technology from SafeNet and Flexera. The Eantime kernel, as well as debugger plugins, check the license and will terminate with respective error messages if no valid license is found on the host. Use the license manager to add a license to your host and also display installed licenses. This host has a full SDK license associated with the disk. Based on the fingerprint generated for the host, you receive the license file. This file then got added to the host. In most cases, runtime license files are issued based on a self-service process through an activation site. The slide shows the activation options displayed by button license. The online activation option is the most frequent one and will be explained here. The online activation option automates the following steps. Gets the fingerprint and sends it to the server. Associates the fingerprint with the SUAC/activation string you entered. Installs the license file, filename/boot/store0, into the node. The console will show appropriate progress messages during this process. Taking this information, you can activate the license offline by doing the steps manually. License shows the screen displayed in the slide only if the system is not yet activated. An activated node will display the activation details, max local nodes, 1 or no limit, max user applications, always no limit, but does not give you the option to activate again. Should you need to reinstall the node, you can reuse the SUAC/activation string entered for this node. Given that the fingerprint got associated with the SUAC/activation string, it cannot be used for another node, i.e. a different fingerprint. Parameters for Eantime nodes in an Eantime for Windows configuration are spread out throughout the Windows registry and other locations. There are many dependencies between parameters and in some cases, changing a parameter requires restarting the Eantime kernel or the Windows system. Wherever possible, dependency is handled by LNC, so the client application does not need to remember that. LNC is used by the standard Eantime configuration utility, inconfig.exe. OEMs can use the LNC library to configure their real-time solution based on Eantime for Windows to their application's requirements. This can be done without any manual user input. There is an example application demonstrating use of the LNC API.